Okay, so I've got an activity on Edmodo, which is task 2 for this, which is having a go at one of these types of tree diagrams. So I'd like to pause now and try that, and then resume when you want to see the solutions. Okay, so this question we've got 6 blue counters and 4 green counters, and I'm going to select them at random, and each time I take a counter, I replace it. So just the same as the example I've already done. The probability of picking each one is not going to change between the first pick, so here, and the second pick. So I'm going to run through here and I'm going to put in my probabilities. So for the first one, a blue counter, it's just going to be 6 out of the total. The total 6 plus 4 is 10. And then for the green counter, it's just going to be 4 out of 10. And then this isn't going to change going forward. So for the blue counter here, probability is 6 out of 10, and green is 4 out of 10. And then the same again. So these are my probabilities for each one. It then asked me a few different questions. So what's the probability of a blue counter and then a green? So that would be going up here to blue and then a green. So the probability of getting a blue, 6 out of 10. Probability of getting a green is 4 out of 10. And it's 6. So a blue and then a green. So multiply. 6 times 4 is 24 out of 100. And I could simplify this. In this case, I'm just going to leave it. What is the probability I pick a blue counter and then a blue counter? Is the second question. So that would be going up this way again. I got a blue and then a blue. So 6 out of 10 times 6 out of 10. So 6 sixes is 36, and then it's out of 100. So right there as a reminder, I've got an and, multiply, got an or, a plus. Last question is a little bit more complicated. So it says, what's the probability that I pick at least one blue counter? So of all the possibilities that are here, I could either get a blue and then a blue. I could get a blue and then a green. I could get a green and then a blue. Or I could get a green and then a green. So the ones of these that have at least one blue counter are this one, blue and blue, this one, blue and green, this one, green and blue. So here I've already worked out blue and then green. And here I've worked out blue and then blue. So I only really need to work out green and then blue. And as you can see from here, that's going to be 4 out of 10, so green and then blue. So it's going to give me 24 out of 100 again. So that is exactly the same as for blue and then green. Green and then blue, 24 out of 100. So it's green and then blue. So the probability I pick at least one blue counter, it could be blue and then blue, or blue and then green, or green and then blue. So I'm going to need to add these probabilities. So 24 over 100 plus 24 over 100 plus 36 over 100. So if I add these all together, I'm going to add up with 24 plus 36, it's going to give me 60. 60 plus 24 is 84 out of 100. And again, I could simplify. Now I'm just going to leave it as 84 out of 100. All right, so this is where it gets a little bit trickier. Before I had independent, meaning the first event did not affect probability of the second event, and now I've got dependent. So this means the first event affects the probability of the second one. So often this will be where items are not replaced into the bag. So I've got my counters again, exactly the same. I've got 3 red and 2 yellow. But each time I take one out, I do not replace it. Now the question is asking us what's the probability I pick a yellow counter, don't replace it, and then pick a red counter. So I'm going to go through this quite slowly. So my first pick, I could pick a red. So I've got all of my counters here. And the probability of me picking a red is going to be 3 out of the total 5. And then here, the possibility yellow is going to be 2 out of 5. So let's follow this arm first of all. So if I pick a red and I don't replace it, what happens? So I pick out a red. So here's my red. I've taken it out. And then when I go to my second pick, I'm not going to put it back in. So now I'm looking at a different scenario. So for my second pick, I've got 2 red counters and 2 yellow counters. So if I want to say the probability of the second pick being red is going to be 2 out of a total of 4. So the amount that is in the bag has changed. And for my yellow, it's going to be 2 out of 4. So that is for my first scenario there. These probabilities change again if I follow this arm. So if I take a yellow, I take that out, I don't replace it, again my probability is going to be a bit different. So if I've picked a yellow first, for my second pick, the probability of picking a red is going to be 3 out of 4. And for yellow, it's just going to be 1 out of 4. Once I've completed all of these, I'm just going to check. So I'm going to go back to each of the picks, so the branches, and make sure they add up to 1. So here, this adds up to 1. 2 out of 4 plus 2 out of 4 equals 1. And then 3 out of 4 plus 1 out of 4 is equal to 1. What the question is actually asking me is what's the probability that I pick a yellow counter, don't replace it, and then pick a red counter. So that'd be yellow and then red. So yellow, 2 out of 5, and then red, 3 out of 4. So that would be yellow, red, and that's going to be, my first one is 2 fifths, so it's this, and then that. I'm going to multiply that by 3 out of 4. So multiply across the top, it's going to give me 6, and the bottom is going to give me 20. So 6 out of 20. If I wanted to simplify that, just half both. It's going to give me 3/10. I could also fill in the probabilities for each of the rest of these, but I'm not going to do that because I already showed you how to do that with each of the ones before. So for instance, if I wanted to find yellow and then yellow, I just multiply 2/5 by a quarter. If I wanted to find yellow then red, do 2/5 times 3/4. So what I'd like you to have a go at is activity 3. So I'd like to pause now and have a look at task 3. So it's a similar question where you do not replace.